is hard water?
Water hardness is a measure of the amount of hard water cations in water. These hard water cations include calcium, magnesium ion, zinc, and the other polyvalent metal ions. In the most water sample, calcium and magnesium are the chief contributors to water hardness. Calcium and magnesium are easily measured by titration with the complex agent ethylene diamine tetraacetate, or known as EDTA.
What is the objective of this experiment?
The objective of this experiment is to learn about the concept of complex metric titration and how to standardize a solution of ethyl diamine tetraacetic acid, or known as EDTA, and how to determine the calcium and magnesium content of water. Next, we proceed with apparatus and chemicals that we need in this experiment.
So I'm using standard titration equipment of a burette, pipette, beakers, conicals and a funnel. I need a 10 molar buffer solution, which I've made already using a solution of ammonia and ammonium chloride. And in the titration, I will also be using a solution of EDTA, a 0.01 molar of EDTA, which I've already produced. The indicator for this reaction is aerochrome black tea. Before
And the procedure is
the reaction, I'm going to first of all rinse the burette. So leave the tap open, beaker underneath. This is deionized water to rinse out the burette. But before I can use the burette, I also need to rinse the burette with the solution it's going to contain. The EDTA is going to be put into the burette. So here I have my EDTA solution. So once the water is all run out, I will now rinse with my EDTA solution. And now that that's all run through, we can now fill the burette with the EDTA solution. I'm now going to fill the burette with EDTA. So pour the EDTA to above the 0 point. Remove the funnel before you start the titration. So remove my funnel, because any droplets that are on the bottom of the funnel can drop in and give you false readings. Then we'll open the tap to fill below the tap. And bring the bottom meniscus to inline with the 0 point. And now our burette is full of solution. We fill below the tap and the burette is vertical in front of us. The burette is now ready to be used. Next, I need to take my water sample. I need 100 cm cubed. So I'm using a 50 ml pipette, which first of all I must rinse with the water that I'm going to be using as my sample. So I'm squeezing the water up. And then let the water run out. And now my pipette is clean. Because I'm using it as a water sample, I don't have to rinse out the solution it's going to contain. It's because the water sample is a solution that it is going to contain. So put your pipette bulb on top of the pipette. And this is my water sample to be analysed. I'm going to press the button marked S to draw the liquid up into the pipette. And this is a 50 ml pipette. So when I see the graduation mark here, and the bottom meniscus is in line with the graduation mark at eye level, I then have drawn 50 litre samples of my water solution. If you overshoot the mark, you can let the liquid run down by squeezing the button marked E. So now I've got 50 cm cubed of solution. I'm going to put this into my reaction conical, press the button marked E, and let the 50 millilitres of the water solution run into the conical flask. So you see, there will be a drop remaining at the bottom of the pipette. You hold the tip of the pipette up the side of the conical flask, hold for a few seconds, and then you deliver 50 cm cubed into the conical flask. I'll now do this a second time, and then we'll have 100 ml of our water sample in the conical flask ready for the titration. In order for this titration to work correctly, you need to add in your buffer before you put in your indicator. So a few drops of our pH 10 buffer into the solution, and then I will add the aerochrome black tea. The aerochrome black tea turns red in the presence of calcium ions. A tiniest amount of a spatula tip is all that's required. And Aerochrome black tea will turn red once it complexes onto the calcium ions in the sample. So we see a wine red colour there. We're now ready to start the titration. So as we titrate, we'll see the wine colour. And that's the wine colour is the complexed Aerochrome black tea with the calcium. As I add in the EDTA solution while swirling, the EDTA is picking up the calcium off the Aerochrome black tea. And when all the calcium is being taken by the EDTA, the Aerochrome black tea will turn a different colour. You should notice it's now turned a blue colour. To demonstrate this more clearly, I'm going to show colour changes. So I'm just taking 100 ml of solution. And here I've got a sample of sodium chloride. If I add sodium chloride into my solution, sodium is a +1 metal ion, and we notice no colour change. However, if I add calcium chloride, which is what the Aerochrome black tea is detecting, so I take a sample of calcium chloride and put it into the solution, you notice the colour turning red. That's because we've got an excess of calcium, so the Aerochrome black tea complexes with this calcium, turning a red colour. Since the sodium chloride didn't react with the EDTA or the Aerochrome black tea at all, we can actually use this property to great effect. If you add some sodium chloride to a sample of Aerochrome black tea, it helps to dilute the Aerochrome black tea so that when your students are measuring it out, they don't take too much of your Aerochrome black tea indicator. Aerochrome black tea ground down with your sodium chloride, and then we can use this indicator in our solution so that when the student accidentally takes too much sample, they can still get the correct color change.
Water hardness caused by calcium 2+ or M2+, which is referred to metal ion. The equation for this experiment is M2+ plus H2Y2- equal to My2- plus 2H+. The volume of the titration, which is 2.85 cm per cube. From the experiment, we also can know the molar for the EDTA, which is 0.01 mole per liter, and we also can know the mole of the EDTA based on the volume of titration, which is 0.01 over 1000 times 2.85 that we get from the titrations, and the answer is 2.85 times 10 power of -5 mole of EDTA. And then we make the comparison, which is 1 mole of M2+ equal to 1 mole of H2Y2- based on the equation, and then we can get the mole for the M2+, which is 2.85 times 10 the power of -4 mole per liter. We also need to find the molar mass for the calcium carbonate to get the total water hardness. So here you can see the molar mass of the calcium carbonate, which is 100 gram. So the moles that we get before, which is 2.85 times 10 power of -4 multiplied by 100, which is the calcium carbonate molar mass. So we can get 2.85 times 10 power of negative 2 gram per liter of calcium carbonate. Lastly, the result 2.85 times 10 power of negative 2 gram per liter must be converted to parts per million, which is we need to times 1000 to get 28.5 parts per million of calcium carbonate. So this is the answer of the total water hardness.
After undergo process of titration, here is the result.
Result obtained show solution change color from red to blue when volume of titration of EDTA at 2.83 cm3. In conclusion, solution changed color from blue to red due to EDTA that remove all of the calcium in Eriochrome black tea.
The solution of titration have been divided into two beakers.
Sodium chloride has been adding in solution, but there is no change. The blue color remain blue due to lack of calcium in the sodium chloride. In other beakers with the same solution, calcium chloride have been adding with the solution. Because the presence of the calcium in the calcium chloride, the solution turned from blue to red.
And the major hardness in water due to calcium and magnesium. As EDTA is added to solution, it combines calcium first and then with magnesium. It is because the EDTA complex more stable.